Throughout this course, we have thus far only dealt with equations that are linear equations. By linear, I mean equations that, when graphed, form a straight line. Another way to describe linear equations is by saying that each variable in the equation is to the first degree, or, in other words, are not squared, cubed, etc. Certainly, there are other types of equations other than just linear, and in this section we will talk about another type known as quadratic equations. An example of a quadratic equation would be x squared plus 5x plus 6 equals 0. This equation cannot be solved in the same way that we have solved linear equations. Let's explore why. A quadratic equation is an equation that has a variable with an exponent of 2. The standard form of a quadratic equation is written in the form ax squared plus bx plus c is equal to 0. And the equation that we are dealing with is x squared plus 5x plus 6 is equal to 0, and it is in the same format. So it is a quadratic equation. Normally, to solve an equation, we have said that you need to get the variable, in this case x, all by itself on one side of the equation. In this problem, however, that's not possible, because it's not possible to combine the two x terms together. You can't combine the x squared and the 5x because they are not similar terms. For that reason, we will use another method known as factoring in order to solve the equation. In Math 101, we discussed multiplying polynomials by a method called the FOIL method. And before we talk about factoring quadratic equations, I want to review that idea. The FOIL method is really using the double distributive property to multiply two polynomials together. FOIL stands for first, outer, inner, last, and is a way to easily do the multiplication. Let's use the FOIL method to multiply the following: x plus 2 in parentheses times x plus 3 in parentheses. With the FOIL method, I want to multiply the first two terms together. So I'm going to multiply x times x, and I'm going to get x squared. Then I want to multiply the outer terms. The outer terms, the x and the 3, so it's plus 3x. Then I want to go through and I want to multiply the inner two terms, which are the 2 and the x. And then finally, I want to go through and I want to multiply the last two terms, the 2 and the 3. So I get 6. Doing that, I have x squared plus 3x plus 2x plus 6, and now I can combine the 3x and the 2x, so I get x squared plus 5x plus 6. Notice that what I get is I get a quadratic, not equation in this point because it's not equal to 0, but I get a quadratic expression because it does have an x squared in it. So, in order to factor a quadratic, we are just going to be going through and doing the opposite of what we just have done. So here's the quadratic expression, x squared plus 5x plus 6. And what I want to do is I want to get it multiplied out. What can I multiply to get to it? I know that the first two terms in it have to give me x squared. So it would be x times x. I also know that when I multiply the last two terms together, I have to get a 6. So now I'm starting to think of what two numbers can I multiply together to get a 6. Well, I could get, say, 2 times 3. I could also say 1 times 6 as I go through. But I know in order to get the outer and the inner, when I multiply those together, I'm going to have to end up with a 5. So I'm trying to think of which numbers could I add or subtract of the 2 and the 3 or the 1 or the 6 to get a 5. And obviously it would be the 2 and the 3. So x plus 2, x plus 3 would give me, when I go through and do the FOIL method, it would give me the x squared plus 5x plus 6. Let's do another example of factoring a quadratic expression. Here I have x squared plus x subtract 12. And if I want to go through and factor that, I know, I'm going to first of all set up by putting my parentheses. I know that the first two terms, when multiplied together, have to give me an x squared. So the first two terms have to be an x. Now, I'm going to be taking a look at that subtract 12. I'm going to be needing to get a subtract 12. And the only way that I can multiply two numbers together and get a subtract, or I could think of it as a negative, is if one of them is a positive number and the other one is a negative number. So right away I can make one of these x plus and the other one x subtract. Now I need to start thinking about what numbers can I multiply together to get my 12. Well, I could multiply 1 times 12, or I could multiply 2 times 6, or I could multiply 3 times 4. But I also know that I have to get a 1 in front of that x when I go through and FOIL this. So I'm taking a look at these three possibilities and which one of those gives me 1 if I add or subtract those numbers. And obviously it would be the 3 and the 4. So now the 3 and the 4 need to go in there. But the question is, where does the 3 go and where does the 4 go? Since this is a plus, I want to get a positive 1. In order to get a positive 1, I'm going to have to put the bigger number, the 4, with the positive, and the smaller number with the negative. And this factors down to x plus 4 times x minus 3. Now if I get to that particular point, I certainly would go through and I would FOIL this again just to make sure that it does work. So my first x times x is x squared. Then the outer x times a negative 3 is minus 3x. Then the inner is plus 4x, and then the last 4 times 3 is a negative 12. If I combine the negative 3 plus 4x, I do get x squared plus x subtract 12, which is what I needed to get and what I had started with. The purpose of this video, though, is to find solutions for quadratic equations by factoring. So let's do the same problem, except make it a quadratic equation. So I'm going to do that, and I'm going to say it's equal to 0. When I say it's equal to 0, I'm going to go through and I'm going to factor it. And since we just factored it previously, I'm just going to put down x plus 4 times x minus 3, but it's equal to 0. Being equal to 0 is very important because whenever you multiply two numbers together, the only way for you to get 0 for an answer is if one of them is equal to 0. So that means either x plus 4 has to equal 0 or x minus 3 has to equal 0. Truthfully, they could both equal 0 as well. That is why it is so important when dealing with a quadratic equation to make sure that the one side is always equal to 0. So in order to factor this and find the solutions for x, which is what I'm trying to do, I'm going to set both of these equal to 0. If x plus 4 is equal to 0, that means that x is equal to negative 4. If x subtract 3 is equal to 0, that means that x has to equal 3. So I have two different solutions for this quadratic equation. If x is equal to negative 4, I would get 0 for an answer. Or if x was equal to 3, I would get 0 for an answer. And I could put -4 in for both x's in the original quadratic equation, or I could put 3 in for both x's, and both times I would get an answer of 0. One thing to remember, because I have an exponent of 2, that's the highest exponent I have, that means that I could have up to 2 different possible answers. There are actually 8 different steps to follow to solve a quadratic equation by factoring. And you can see that I have all 8 steps listed here. What I'm going to do is I'm going to go through each one of these steps with this problem that I have right now in black. So the very first thing, step 1, is be sure that one side's equal to 0. Right now the right-hand side is not equal to 0. So first thing I'm going to do is I'm just going to subtract 5 from both sides. And when I do that now, I have x squared subtract 5x plus 4 is equal to 0. So that's the quadratic I'm going to use. The second step says to find factors for the quadratic by setting up 2 sets of parentheses. So I know that I need 2 different sets of parentheses, and I'm going to end up having 2 terms in each one of those. And the very first thing I have to do is I have to determine what the first 2 terms have to be. That's step number 3. Well, I know that it has to be x squared, so the first terms are going to have to be x and x. Step number 4 says determine what the operation signs must be in each set of parentheses. So I am taking a look at this symbol right here. That sign is addition. In order to get a plus 4, that means that this sign and this sign have to be the same. They could both be positive positive, because a positive times a positive is a positive, or they could both be negative, because a negative times a negative is equal to a positive. Well, I know that they both have to be negatives, because I'm going to have to end up with a negative number here when I go through and add or subtract. So I know right away that this has to be a negative. I also know that this has to be a negative. Step number 5 says determine possible answers for the last 2 terms. So I'm taking a look at this 4. The way to get 4 is I could multiply 1 times 4, or I could multiply 2 times 2. Once again, I know that when I use these, I have to end up with a 5 by addition or subtraction. Well, the only way I can end up with a 5 by addition or subtraction is if I have a 1 and a 4. So one of these is going to be a 1, the other one is going to be a 4. So now I have gone through and I have x minus 1 times x minus 4. Step number 6 says plug in the possible numbers for the last 2 terms and check by the FOIL method. So I do want to go through and make sure that I can FOIL this, and this will FOIL correctly. So x times x is x squared, then the outer minus 4x. Here's the outer 2 terms. Then the inner 2 terms, minus 1x. And then the last 2 terms, -1 times -4, is equal to plus 4. If I go through, I do get x squared subtract 5x plus 4, which is what I had for my quadratic. Now I want to go through and find out, well, what is x? I'm going to write down the factors again. What are the possible values for x? The factors were x minus 1 times x minus 4. So what I have to do is I have to set each factor equal to 0 and solve for x. If x minus 1 is equal to 0, x is equal to 1. If x minus 4 is equal to 0, x has to be equal to 4. So those are my 2 possible answers. Then, once again, the very last thing it says is to check your answers in the quadratic equation. So I would come back up here to my quadratic equation for both of these. I would put both of those in for the x and see if I get 0. And I will leave that to you. It certainly would work and give you 0 for the answer. There is another special type of quadratic equation known as a difference of perfect squares. And here's an example of that. X squared subtract 49 is equal to 0. This is a difference of perfect squares because, first of all, I have a difference. Subtraction means difference. And I also have squares. X squared is a perfect square, and so is 49 a perfect square. So it's known as a difference of perfect squares. I'm going to rewrite it here. It really factors down the same way. I'm going to set up my two parentheses, and my first two terms have to be an x and an x, because x times x is equal to x squared. Now, I don't have a middle term, I just have subtract 49, and since this is subtraction right here, I know that one of the signs has to be addition, the other sign has to be subtraction, because that's the only way I can multiply those two numbers to get a negative number. Because this is 49 right here, I also know that 7 times 7 is 49. I'm going to take the square root of 49. So I have x plus 7 times x minus 7 is equal to 0. If I set both of these equal to 0 now, x plus 7 is equal to 0. That must mean that x is equal to negative 7. X subtract 7 is equal to 0. That must mean that x is equal to 7. So the two possible answers for this are negative 7 and 7. I do want to go back just for one moment just to show you. If you have x plus 7 times x minus 7, remember I had always said that we could go through and we could check this by doing FOIL. X times x is x squared, that's the first. Then the outer is subtract 7x. The inner is add 7x. The last is subtract 7 times a negative 7. I get negative 49. And notice that these two terms here drop out. So I do have that x squared subtract 49, which is what I started with. This is just another example of a quadratic equation that just looks a little bit different. The only way to get really good at this is to practice, but this video is already pretty long. So I'm going to ask you to go to the next video and practice doing a few of these problems yourself. After each problem, you will be able to watch me as I also do them.